ArcGIS Online is a complete cloud-based system. This is true now more than ever. I'm going to show you 3 demos of recent enhancements in online in the area of mapping, performance, and data management. Well, mapping starts with data. ArcGIS Online gives you the power to take your raw data, bring it into your system, and create useful geographic information. Here's the Zillow Open Data site. It provides data for the current month and different geographies. I've gone ahead and downloaded this zip code CSV file and brought it into the map viewer. I see I have about 13,000 records, but it's not spatially enabled. I can use the analysis tools of online to join those features together. I can join it with my own data layers, or I can use one of the Living Atlas layers. And those Living Atlas layers have things like zip codes, so I don't have to do anything. It's just right there for me. I can do spatial or attribute-based joins, aggregate, and so forth. Once joined, I can actually work with it and map it. So let's look at the Zillow home value. Smart mapping allows me for easy data exploration. I can explore the data, look for interesting patterns, like in this case showing me high to low, but maybe I'm interested in above and below the national average. The data's right there. I see the national average for the home price is around $250,000 within each zip code. Now that tells me one side of the story, how much houses cost, but I'm really interested in how much they cost in conjunction with how much people make. Now to get that kind of data, I can again use the analysis tools and enrich layer and pull in the income information, in this case the 2016 average household annual income. Once pulled in, I have the variables I need to make the map I want. Now in this case, I need to create an expression that will allow me to combine those together. So let's paste one in here. We're going to round the house price divided by the average household income to 2 places. I can test it out. Looks good. Bring it into the map. And maybe switch to color. And here, we'll see that, let's just switch this to 2. And switch this to, let's say, 10. So I really see how much it costs to buy a house in conjunction with how much people make. And, pretty striking map. So how did I create that expression? Well, that's new feature in ArcGIS Online and in 10.5.1 ArcGIS Enterprise, which is Arcade. Arcade is the platform scripting and expression language for web maps and eventually web scenes. You can author these expressions in Online or in Pro and consume them in the map viewer, your custom JavaScript application, eventually your Runtime application, and the ArcGIS native apps. Arcade is simple, portable, and secure way to bring your expressions across the platform. Now I want to move to performance. ArcGIS Online recently leveraged a content delivery network, or CDN, to dramatically improve the performance across the world. Let's take a look at this public service of mine, and first let's load it without using the CDN. I'll see the queries there on the right and the times that they took. Let's load the same exact one, but this time over the CDN. Now, we'll see a couple things here. Notice that the protocol is all HTTP 2. This is the latest in the HTTP stack for improved performance between the browser and the server. I see times in general are smaller than the previous one, and this is available globally. So if I'm in Australia, I'm going to go to the closest CDN known to pull my data down. This is not just for feature services, but this is also for raster and vector tiles and scene services. And the request pattern with scene services really benefits from this HTTP2 aspect. In fact, we're seeing 3 times decrease in the load time for certain scene service layers. Now let's talk about a little bit about data management. We recently had an election, and the New York Times did some pretty amazing graphics. They had pretty compelling maps, but what was also interesting is they were updating the data as new results came in. Let me show you how you can use ArcGIS Online to make this map in this scenario in minutes. Okay, I've got, in a future election, the election 2020, I've got data for the 2 candidates. In this case, Ewan from the Hair People's Party and Jim from the Bald People's Party. From there, I can also rotate the symbology and rotate it based on the percent gap. So the arrows pointing to the left completely voted for Jim. The arrows pointing to the right completely voted for Ewan. And areas where it was straight up and down means it was a close election. From there, I can also now size those arrows based on the total number of votes, just simply by summing up the vote counts. So I see areas like Chicago and Los Angeles have much bigger arrows because they have a lot more people. Now, this layer can be brought into a web map, which again can be shared to the public. This is the one that the public consumes and visualizes. With online, I can create different views of my data. So I can create a view which will allow me to set different settings, like editing settings, set different capabilities, and also control who I'm sharing this layer with. This view is pointing to the same data as the election map. So let's turn on editing with this layer. And let's share it to the election results data stewards group. So only the people in this group will see this view of the data. Now I'll go to the data and find Los Angeles County. And let's exaggerate it so that you can see it on the map. Go back to the map, enable refresh interval. So in 6 seconds, Los Angeles County, the blue arrow, should update and become a red arrow pointing in the other direction. Okay, so this morning I've shown you how you can bring your data and easily map it with Smart Mapping and explore the data. We see the performance increases, and we also see the capabilities you have to create dynamic applications in a secure way to present your story to your users. And now I'm going to turn it over to Jennifer, who's going to talk about the Living Atlas and the content that's available there, and also vector tiles and how you can create your own vector tiles. Jennifer, take it away.
Thanks, Jeremy. Hi, everyone. I'm on the Living Atlas team. The Living Atlas of the World is the foremost collection of global geographic information used to support critical decision-making. Here we can browse through the thousands of maps, layers, apps, scenes, and tools. One of the most popular layers in the Living Atlas is the World Imagery layer, with 9 billion requests made last month for this map alone. The Living Atlas is organized into categories and subcategories from imagery, demographics, Earth observations, and urban systems. So let's take a look at the base maps category. Here we can explore a variety of vector tile base maps available for you to use today. These base maps, which we released last year, have just come out of beta and are accessible across the platform. What I like about these base maps is that they're easily editable. Let's look at some fun examples. Here we have the newspaper-themed vector tile base map, mid-century, dark blue canvas, colored pencil, and even Pokemon Go. These vector tile layers aren't just for Esri base maps. Developers and people in every field who want to share their data with the world can do so by publishing vector tile layers in Pro. These layers are powered by the Open Vector Tile specification. This is a recent project where we used vector tile layers to highlight the opioid epidemic found in the US. So let's look in Pro to explore the map behind the story. This map shows high rates of opioid claims in bright blue. We've got state, county, and zip code layers that are all set to show at different scales. We can use Smart Mapping in Pro to set the transparency on a specific field. So we can see that the average of our data set is around 5.5. So what this means is that out of all the prescriptions made in the US, around 5.5% of them are opioid claims. Anything above the national average is given a solid bright blue fill, and anything below the national average is given a transparent magenta fill. So this above and below mapping style really brings your map to life and provides a comparative analysis from one location to the next. So when we're ready to share a map with the world, we can do so as a web layer. All of your layers in your map will be combined into one vector tile layer that can be published in any projection. So we've already published this layer in ArcGIS Online and brought it into this Cascade story map. So notice the seamless transition as we pan to the Pacific Northwest and zoom in to the zip code level. This really is a great example of a policy map where areas of possible change or improvement are easily noticeable, in this case, counties shown in bright blue. So with a combination of vector tile base maps, vector tile layers, and smart mapping in Pro, we now get a clear and performant visualization of our story. Thank you. Back to you, Jeremy.
And now I'd like to turn it over to Jan, who's going to show us enhancements in the JavaScript API in the area of 2D mapping. Take it away, Jan.
Thanks, Jeremy. First, let's see how seamlessly the JavaScript API 4x integrates into the ArcGIS platform. I've created this map with the topo base map, and then the map view to render this map on the screen. And then I quickly added the same layer as Jeremy authored using the layer ID, using the method layer from portal item. So this method grabs the layer configuration and figures out for me which layer to create. And then I get a layer that I can quickly add to my map. So it's really easy to author a map on ArcGIS Online or on-premise and then share it. Now let's look at some of the latest enhancements to the 4.3 to the feature layer. We just added the new apply edits method that allows the user to make edits on the feature service. So this sample that is also available in the latest JavaScript API SDK display a form so that the user can report incidents. He can add an incident and enter some description and contact information and update the attribute of the feature I just created. We also added the features on demand. So in 3x, you can set on the feature layer the mode, how it will fetch features. So it can either fetch on a single snapshot of the features on the client or do on demand. In 4x, we have simplified the developer experience by doing the right thing based on your data. So as I pan around, the feature layer makes additional requests in a tile manner that is cacheable on the web browser and also at the CDN like Jeremy showed. So that works great at this high scale, but then what about large data set at small scales? You can already display them using the vector tile layer and WebGL that displays vector tiles as with WebGL. Well, we are working on a new rendering for the feature layer 2 that will take advantage of the GPU. So I'm really excited to show this early sneak peek of what's coming to the API later this year. I will be working with this layer. It contains the presidential election results from the 2008 election. So we have the number of votes for Democrats, the number of votes for Republicans, for each precinct, which is a voting district in the United States. So we'll add this layer in this map. It's about 180,000 features. The layer makes requests to fetch the data, but then makes as many requests as it needs to display the entire data set. So these are the different tile extent that we have fetched that we have issued to fetch all the features. Now let's look a little bit at how it looks in New York. So this is a lot of points, but what we can do is use smart mapping, for example, to visualize where the people massively voted for one candidate or the other. So here I've just clicked in one of the very blue area, and we can see that 99% voted for Obama. Let's go back to the country level. Yep. So that's nice visualization, but now what I can do is also move my slider and show, instead of the voting districts that were very close, the voting districts that were very contested. So as I slide, my layer updates in real time using the GPU. And then I can even animate. Yeah. Woo! So we are looking at bringing this capability to the 4x API this fall in 2017.
That's awesome.
Thank you. Back to you, Jeremy.
That's great. It's great to see how fast, how much you can do on the GPU once you efficiently get the data there. That's 180,000 points, just seamlessly changing and interactively working with it. That's great. Can't see what you guys do with that when we pull that out. All right, now Devesh is going to show us the runtime and enhancements in mapping within it. Take it away, Devesh.
Thanks, Jeremy. Maps are a common language of the ArcGIS platform. And with the latest release of ArcGIS Runtime, this language extends to your native apps. No matter what tools the author used to create their maps, your applications can put those maps in the hand of decision makers and knowledge workers where they're most required. Simply put, maps work everywhere. To give you an example, I have here a map that I authored in ArcGIS Online. It shows the healthcare facilities in the greater New York area. I can go ahead and tap on one of these facilities and get more information about it in a pop-up. And this map's also using the new newspaper vector-based map theme that Jennifer mentioned earlier. If I go ahead and switch over to my iPad device here, I have a custom iOS app that was built using the ArcGIS Runtime SDK for iOS. Now, I've already logged into this account, and so I can get access to all of my maps. Let me go ahead and open that map we were just seeing on ArcGIS Online. And you see I have access to all of my maps and data. I can even go ahead and tap on one of these features and see the same pop-up information on my device. And these new vector-based maps look just gorgeous on these high-resolution devices. But that's not all. Because Runtime allows me to modify my content or even create completely new content on the device. So I can go ahead, change the base map. I can search my organization for layers, add them to the map. I can reorder my layers, and even change things like transparency or renderers, basically anything that a map author would like to do. And when I'm done, I can go ahead and save my changes. And if I switch back to my Mac and refresh the browser, you'll see that all of the changes I made on the iPad are reflected in online. So thank you. Let's quickly take a look at the code that's required to build such an app. I have here Xcode, that's the IDE Apple provides for iOS development. And we're looking at Swift code that a lot of the iOS developers would be familiar with. Opening a map is as simple as taking the item the user picked, creating a map, and setting it on the map view. Changing a map is just as simple. So modifying the base map is as simple as changing the base map property of the map. Adding, removing, or reordering layers is as simple as managing the operational layers collection of the map. And when we're ready to save our changes, that's easy too. Saving the existing map can be done with a single call to the save method. But if we want to create a new map, then we can call save as and pass in additional information like title, description, and thumbnail. So you see, the runtime provides really coarse-grained, workflow-oriented APIs that do a lot of the heavy lifting for you. This frees you up to focus most of your time on the important things, like implementing the business logic and refining the user experience. So that's an example of working with maps online. But many of our apps need to work offline in disconnected environments. ArcGIS Pro is a great tool for authoring such maps. If I go ahead and switch over to my Windows machine, you'll see I have a project that shows the water utility network of the city of Naperville. I have 3 maps in this project. Each serves a specific purpose. For instance, this map shows the location of water mains and laterals that can be used by construction crews. The emergency response map shows the location and type of valves, which can be used by workers to shut off water in case of an emergency. If we look closely at the cartography of this map, you'll see that the layers use complex domain-specific symbols that are actually required by the workers to do the right thing. Now, I can save this map to online and use it on my iPad like I did before, but since we want to be able to use them offline, I can use a geoprocessing tool in ArcGIS Pro to create a mobile map package. A mobile map package is a portable, file-based format that makes it really easy to transport and distribute your maps for offline scenarios. It's a single self-contained file that contains the map, its symbology, and its data. And it can have even more than one map. So in this case, I'm adding all 3 of my maps in the project to the package. The tool's smart enough to know that if all of these maps reference the same underlying data, then it can package the data just once, leading to a very compact format. The tool will include the map's base map and its operational layers. And if the map's using other assets like a locator or a network dataset, then that can be included in the package as well. In this case, I'll go ahead and add this composite locator in my project that helps me to find addresses and features. Now, I've already created this package ahead of time, so I'll switch over to this custom WPF app that was built using the ArcGIS Runtime SDK for .NET. As you can see, it's showing me all of my maps. I can go ahead and open one of them, and you see I have access to all of my map layers and symbology. But since the package also contains the data behind the map, I can go ahead and tap on one of these features to identify it and see its attributes. And since I included that locator in the package, I can go ahead and search. And I get suggestions for addresses and features in my map. And all of these capabilities are being driven by the runtime locally on the machine using the contents of the package. The application does not need any network connectivity. So let's quickly take a look at the code required to build such an app. I'll jump into Visual Studio. And since this is a WPF application, it's using the MVVM design pattern that a lot of .NET developers would be familiar with. When the application starts up, it creates the mobile map package using the file on disk and instantiates the first view model. The first view then uses XAML bindings to iterate the maps through the map package and displays each map's title, description, and thumbnail. When a user picks a map, the next view then binds the map to the map view. And when the user searches, we use XAML bindings to get the view model to pull the locator out of the mobile map package and call suggest to get results. So you can see that the runtime API feels very natural inside our MVVM and XAML. And those were just some of the examples how ArcGIS Runtime is bringing the power of maps, both online and offline, to an app near you.